5.2. Polynomial. Okay. So first thing I want to do is divide. That's not good. Um, 351 by 4. So if you recall, whatever you divide by goes on the outside. So 4. Oops. 4, 3, 5, 1. Does 4 go into 3?
No.
No. So then we're going to go ahead and look at 35. 4 goes into 35 how many times? I believe it's 8. So first thing we said 4 divides into 35, so it's 8. And 8 times 4 is 32.
32.
And technically at this moment, that 32 is a positive. When now we're going to subtract, which means we put a negative here, which switches that sign from a positive to a negative. This brings it down to 31, and then we bring down the 1. So it's all the way through one time. So we did 4 into 35 gives you 8. We multiplied 8 times 4 gives you 32. Subtract, when we change that sign, give us 31. Now we do it again. So 4 goes into 31. 7 times. 7 times 4 is
28.
28. And then when we subtract, this sign becomes minus, leaving us with 3. And since this 7 right here is over the last column in our division, that means the last time through. And so this gets to be our remainder. So I can say this is 87, remainder 3. Or more preferred be 87. And I have 3 pieces left over that are, so divided by 4, they are 1/4 in size. So division kind of works like here's division. Step 1, we're going to divide. 2, multiply. 3, subtract. 4, you can repeat as necessary. Is 4 a factor? What do you think? Is 4 a factor of, oh, not 4, 8, not of 87, of
351.
1. Is it a factor of 351?
No, because it doesn't zero out.
No, because the remainder is not 0. Oh. There we go. All right. So if I look at something like, I don't know, 4 divided by 20, right? 4 goes into 20 how many times?
5.
5. Then 5 times 4 is 20. I subtract it, it gives me 0.
So 4 is a factor of 20.
So, in fact, 4 and 5
Factor
of 20. Remainder is 0. I should come back to this one up here because you. Remainder. All right. So long division.
Oh.
All right. How about x squared plus 2x minus 24 by x plus 6. So who goes in the box?
X squared plus 2x minus 24.
Right. So whatever comes first goes in the box. X squared plus 2x minus 24. And whatever I divide by is out here, x plus 6. Now when you do long division, really you're just going to be working with this part. So you only divide with the x, and you multiply with both the x and the 6. So you can say to yourself, there's 2 ways of doing it. You can say, okay, x times what gives you x squared?
X.
X. I'll take the x. This is the x squared column. This is the x column, and this is the constant column. So I'll take the x and put it in the x column. Then we're going to multiply. When you multiply by everybody. So x times this x here, x squared. X times plus 6
Oh.
plus 6 x. And then we're going to subtract, which means everything on this line switches. So this becomes minus, and this here becomes a minus. And x squared minus x squared is 0. Your first subtraction should always be 0. Your first column subtraction, like up here on the 4 times 5, this is actually a 0 right here too. Then we're going to have 2x minus the 6x, which gives you minus 4x. Bring down the next value, so minus 24. So we've divided, we multiplied, we subtracted. Now we're ready to ask, do we repeat again? And we keep repeating until I have a value right here. So there's no value here, and we keep repeating. So come back to your x. X times what gives us minus 4x?
-4.
-4. And then we're going to multiply. Minus 4 times x is minus 4x. Minus 4 times positive 6 is minus 24. And then on the subtraction step, all these signs switch. This becomes a plus. This becomes a plus. So I get minus 4 plus 4x. Minus 24 plus 24 is 0. So x plus 4 is our solution. Now, since the remainder is 0, what do we know? X plus 6 and x minus 4 are factors of x. And you guys know what the x caret 2 means right here?
X to the power of 2.
Right. Now, a couple things to keep in mind when you do long division, and synthetic division for that matter, is first, you have to be a single order, right? It has to go x squared, then x, then constant. So you start at the highest power and you go down. The other thing to keep track of is if you're missing anybody, right?
Yeah, to throw in 0,
Right.
whatever. So if you are missing one, say you are missing x, you would have to throw in 0x.
Right. Let's do a little more complicated one.
Oof.
It gets better. So it's x to the 4th.
Really?
Yeah.
Really?
Did you guys did you get this on your assignment?
I'm barely positive I've got a couple like that on the assignment, yeah.
Yeah. So I thought it might be good to look at one before we. Let's make that bigger. So inside. Outside. It's so pretty. All right. My wife just whispered, "It's only pretty to you."
Oof.
She's not really a math person. Something wrong with her. Now, on this problem, note that x to the 4th, I have x to the 4th, and I skip to plus 1, right? So I'm missing a whole bunch of stuff. X to the 4th plus 0 x cubed plus 0 x squared plus 0x plus 1. So I have all those placeholders now.
I think when I went through the assignment, the only one, I never had a question where it was missing more than one of the exponents.
Yeah,
One of the x's. So it was like x cubed plus x1 plus I or whatever, and it was really.
I mean, this one's not going to be bad because the divisor is x squared. So our first division is going to put us right over this.
Yeah.
So the more terms you have in here, the bigger it gets. So most likely you probably get a lot of things more than degree 4 or 5. Because even though it's the same, the bigger it gets, the harder it becomes.
No, it never got bigger than 4.
Yeah. So right here, you'll note the divisor starts with x squared. There's no x. And is I a constant or a variable term? Go ahead. I is a constant or variable?
Wouldn't it be a constant?
It's constant. So out here it's going to be x squared plus 0 x's plus our constant, which is I. And again, it doesn't matter what's going on. This stuff here doesn't matter. 0x and I doesn't matter. We're only dividing by that.
Squared.
So x squared, what times x squared will give you x to the 4th?
X squared.
X squared. Again, our columns are separate, right? Nothing but x to the 4th in the first column. Nothing but x cubed to the next column. Nothing but x squared is here. So x squared times x squared gives you x to the 4th, so it'll be x squared. They're going to multiply. X squared times 0, x squared is x to the 4th. X squared times 0x is 0 x cubed. X squared times I is positive I x squared. And then we subtract, so minus, minus, minus. 0, 0. 0 minus I x squared is I x squared. Bring everybody down. Plus 0x plus 1. All right. So what do you have to multiply this guy right here, x squared, by to get minus I squared? Minus I x squared. All right. Should just be that coefficient of this, so I'm going to multiply minus I. Now minus I is a constant, so I'm going to put it over the constant column, which means this right here is a 0. Then you multiply. Minus I times x squared is minus I x squared. Minus I times 0 is 0. Minus I times plus I is minus I squared. And let's do a quick look here. I squared, right? I squared is minus 1.
Yes.
This becomes minus 1 or a plus 1. So minus I squared is plus 1. So now we're ready to actually do subtraction. So that means this is a plus, this is a minus, and this plus 1 is actually now a minus 1. So 0, 0, plus 1, minus 1 is 0. So our final answer, x squared minus 1 minus I. Is that okay?
Yeah.
Yeah, you probably won't see very many of those. Those are pretty tricky. By the one-dimensional one.
Where I have more struggles with synthetic division.
Really?
Yeah.
What about synthetic
But
division?
it wasn't. The only time I had struggles with synthetic division, though, was when it incorporated, like, 2x plus I or something as a thing
As a divisor.
So 2x plus I in parentheses or something like that is where I was having struggles. Where it turned into a binomial is where I was having troubles. So when it went from x squared to, so say it was x to the fourth plus parentheses 2x squared plus I or something like that. That's where I was having struggles.
All right. Sure. So synthetic division works only for x plus a and x minus a. That means this has to be a 1 right here. This has to be a 1 right here. And the exponent has to be 1s. A itself, A is complex. So divisors can be like, well, divisors can think x plus 2, x minus 5, and even x minus I, or if you want to be really crazy and mean, this would actually work for synthetic division because this thing here is your A value. I doubt they gave you one like that, but it's a possibility that you could actually do it that way. I sure wouldn't want to.
They didn't give us one like that. I'm a little surprised they didn't, but
Well, that one gets kind of tricky to keep track of the.
Well, the example they used in the lesson on Hawks had that.
Did it really?
Yeah.
My example's gonna be a little bit kinder than that.
So it kind of confused me when I went through it the first time, going, what am I supposed to do here? That doesn't make any sense.
That's a big jump to see that the first time.
I told them to, I mean, sometimes in the students feel like it doesn't get changed as frequently,
But when I went back to it the next day, it was like, oh, that's what I'm doing.
Yeah. You can do it, but it makes it much bigger than you expect.
Yeah.
kind of thing, but the students will influence
All
that
right.
more often.
So let's do something a little kinder.
It's never empty.
Boy.
Why cheaper? Why didn't she put it in? She had to change the date, in hopes that we get released then for her dad's visit, so that's the week before I'm supposed to
Okay.
take mine for release.
So who is the divide? Who goes inside? Who goes
Why
outside?
couldn't she put it in? Oh, okay.
This should be the inside. Right. And where your divide by is on the bottom, so this is the outside.
No, I hadn't heard yet. I knew she was working it out with.
And
She had talked to,
we set up synthetic division. You
that
kind of want to think about using 3 lines on notebook paper.
finalizing approval kind of thing. And
So-
hope it work out. but
When you do it inside here in this first row, you just put coefficients. So it's going to be
how many
1,
that
1, the minus 18, and the plus 9. So 1,
Airbnb
1,
or like a month apartment or something,
minus 18,
but I hadn't heard an exact date.
plus 9. Now on the outside, you take the opposite of whatever this is.
She has to do.
So if it's plus 5, it's minus 5, whatever. So it's going to be minus 5. And step 1,
Okay.
once you have it all set up, step 1 is just take whatever this number is here, pull it down. And then we're just going to be multiply, add, and subtract.
Well, because I think.
1 times minus 5 is
240 hours, so she was gonna try.
minus 5.
Done.
1 minus 5 is
When I look back, the two.
minus
that'd be
4.
about right, probably, because the two.
Minus 4 plus 5. Sorry. Minus 4 minus 5
For my degree was 240 hours.
is 20.
I was just lucky enough
Gives me positive 2.
at the city.
And 2 times minus 5 is minus
So
10.
like I worked, for my practicum, I was working at the zoo every day, but 3 of the days were.
And now we just need to interpret.
full-time Practicum, not
So-
paid into their keeper area.
Take x
And the
cubed,
other
right?
4 days were my normal work days.
If I divide x cubed by this x, power reduces by 1, which means my answer will be 1 less. So I start with x cubed, and you divide by x, the power reduces by 1. So this here is
If she's working.
1
you have to do it 6 weeks if she's working.
x squared. There is a count down, minus 4x, plus a constant of 2.
Time.
And once you get to a constant, that means this right here is a
Yes, she'd be gone
remainder.
6 weeks.
So I'll put minus 1 over
Get-go, but it wouldn't
my
start
divisor
until
of x plus 5.
Yeah. So it was basically gonna be a 6 week, like somebody's on maternity leave kind of thing.
So the 1 is not necessarily x squared.
She should be graduating
Put
this
there.
coming December.
All right.
If all this is going on now, does not push things.
Do you want to try something else? I'm done. So if you want to try a more complicated synthetic division, we can.